Today we will be discussing about Unit 2.4 in the Solar PV installation course, and that is covering inverters. So first of all, we will define an inverter. So what is an inverter? In the previous unit, as we have studied in the working of the solar modules, that solar modules, they are producing DC. Now, on the other hand, the load, household load, common domestic load, as well as also we can consider industrial load, because most of them are using three-phase induction motors in the manufacturing. So the requirement is for AC. Okay, another thing that solar availability is not throughout the day or whole 24 hours, because in night the availability is not there. So we need storage. So commonly battery storage we use. Okay, another thing that batteries, they are also storing power in the form of DC. So the transition of DC power to AC power, that is required before we can utilize it for any type of application. We want to run some appliance, some machines. So that a more common practice is that we are needing a AC supply. The transition of DC power into AC power can be done by using inverters. Inverters are converting DC into AC. So this is shown in the this diagram 2.4.1. So input, that is DC, and output, that is AC. So the main functions of inverter, they are shown in the figure. So converting DC electricity into AC, just we discussed. Then wave shaping the produced AC electricity. Wave, that is a sinusoidal wave, commonly which we are using. So it should shape the wave. And another function is regulation of the value effectiveness of the produced voltage, which it has to regulate, okay, the effectiveness of the produced voltage. Now inverters for PV application, like in our case, we are using it with the solar panels. So maximum power point, just we discussed in the previous unit, the maximum power point, that is the specified power or the point on the curve, VI curve, in the characteristics of the solar panel, and this point will correspond because it gives the maximum power output from the solar panel. The high switching frequency inverter with a 20 kilohertz or higher frequency, okay, that is possible because of switch mode semiconductor power devices. Commonly power devices which we are using, like the MOSFETs, bipolar junction transistors, the BJT, MOSFET. So these are preferred for low power level inverters because we need very frequent switching. So semiconductor devices like this MOSFET, BJT. Okay, another thing for high power level, these are not sufficient. MOSFETs and bipolar junction transistors are not sufficient to deal with high power. So there we need thyristors. So they are the suitable power devices and semiconductor based power devices which very efficiently perform these switching operations at very high frequency. So if a frequency of up to 50 kilohertz is even more, very high frequency that is needed, then IGBT, that is insulated gate bipolar transistor, they are preferred. They have the capability to handle several hundred kilowatt of power, delivering an AC production wave. Again, the output, that should be pure sinusoidal. So we are getting it from the IGBT. Okay. So the process restricts large energy consuming and expensive power filters. Okay, because in the this semiconductor devices, we see that the resistance, that is almost negligible when we want to conduct. So basically they are doing switching operations, switch on, switch off, conduct. Controlling is easy. as moving parts are not there. So efficiency that is high. And this is the requirement for the inverter, that it should be reliable and it should be efficient. Both of these requirements we are getting from this semiconductor power devices. The solar inverters have some unique function modified to work with PV arrays. Means there is a little difference between the normal inverters which we are using in the household and the solar inverters. So they are specially designed to work with solar arrays. So one of these requirement is the maximum power point tracking. Another thing, anti-islanding safety. I will cover it when we needed anti-islanding safety. Okay, islanding indicates a state when a distributed generator persists powering an area when the grid power is not available from the utility. Okay, I will discuss it again in my coming topic. So solar microinverters are not the same as the regular inverters. Because each solar panel has a single microinverter connected to it. Means these microinverters, they are connected with the solar panel itself. The total efficiency of the system can be enhanced due to this. The collective output from all of these micro inverters, that is supplied to the electric grid. Now, type of solar inverter. So three types. Basically, we are dividing the solar inverters into standalone inverter, grid tie inverter, and battery backup grid tie inverter. Okay, so first of all, standalone or off-grid inverters. So these type of inverters are preferred for standalone PV system, and standalone PV system is not connected. Usually, it is not connected to the grid. There is no power purchasing or supplying from the grid. I mean, this is usually an isolated load, some type of remote area that can be covered by using the standalone PV system. So there the grid supply is not available. So locally we are using solar panels, we are generating the electricity and we are consuming it inside the load. Like the house is in the some village and village is not connected to the grid, electricity is not there. In that village we can use this solar systems, and the electricity which is generated, that is consumed inside the households in the village. So we are not purchasing anything from the grid. So that is a standalone mode. So there, because every time the solar availability is not there during night, we are not having this electricity from the solar panels. So in that case, a battery backup that is needed. I guess because we need a storage. During daytime, we will store energy there in the battery, and during night, we will take electricity from the battery. Because standalone inverters are called standalone. Their name are so called because there is no need to attach them to the solar panels. Because they are not connected to the solar panel, they are receiving electricity from the battery. So PV arrays are used to charge the battery, and from the battery, the electricity is coming through the inverter that is going to the load. Some standalone inverters are coupled with the battery chargers to refill the battery, means charging as well. So for both of the tasks they can perform. Since standalone inverters are detached from the utility grid, they do not need anti-islanding safety. Okay, now I shall consider this anti-islanding safety means that is something which is corresponding to our next type, that is grid tie inverter. So here in the grid inverter, these inverters are usually connected to the grid, and there we necessarily we do not need any battery backup, because during the daytime we are generating electricity, consuming in the load, surplus electricity we can supply back to the grid, and during the non-availability of the sun, night, this type of situation during night, we can take electricity from the grid and then we can supply it to the load. Okay, so the frequency, because the grid, the frequency that is usually 50 hertz, could be up and down a little bit. 14.5 could be there. Okay, depending on the load and the generation situation. a mismatch or something. Okay, so that should be matching because the energy which we are supplying, feeding to the grid, that should be having the same voltage and frequency as that of the grid. So the grid is performing the task of a battery backup in this case. Like in the previous standalone system, battery was supplying the electricity in the absence of the solar availability. And in this case, the grid is performing the same function. Now what happens is, in this case, if there is some fault in the grid, okay, and it has been tripped off by the protected devices, so energy should not be there in the grid in that case, because we have to clear the fault first. After that only we can resume the electricity. Now, in that case, if our solar panel is generating electricity and it will feed it to the grid, surplus electricity that will be fed to the grid, and but the electricity should not be there in the grid at that time when there is a fault. So this is the situation that our inverter should detect it, and it should uh, not let the electricity enter the supply to the grid. So this is anti-aliasing mode. Just we discussed in the previous one. So in the standalone mode, we don't need any type of such type of system, anti-aliasing protection system. But here in the grid tie system, we do need. So here the diagram that is showing the same purpose. Solar panels, they are generating the electricity from the utilizing the solar energy through the charge controller. The energy that is being supplied, the inverter converted to AC, then to the house, surplus energy to the grid. Okay, so yes, grid tie inverters need anti-aliasing protection in their system. They should not supply electricity to the grid in case the grid is not grid should be not be having electricity, like in the cases of faults or like that. So anti-aliasing protection system that is needed. Now this battery backup grid tie inverter, this is a combination of both of these two types which just we studied. They have a battery backup, also they are connected to the grid. Okay, the battery backup inverters are designed to draw electricity from battery and regulate that with its on-board charger. So they supply extra energy to the grid. So these energies can provide AC power to chosen areas where energy is needed at times of power interruptions. So they are having their own storage as well. So they also need anti-aliasing protection because we are supplying power to the utility grid. So it is shown here in the diagram here. Almost similar system as we just studied in the previous one, except for that we are having a battery bank as well. Okay, so I think we shall stop here. Okay, now one more topic is there. We shall also cover it. Efficiency of inverter. So efficiency basically of a moving device. Okay, some type of machine, generator, motor, anything like that, that is usually low as compared with a static device. Why? Because friction, windage, these things are not there. So inverter, that is also a static device. So the efficiency that is high. But as per the designing, as per the working of any type of machine, not only inverter, almost all of the type of machines, other equipments, including machines, the maximum efficiency that is obtained when our system or the equipment or the our machine, I think it is working on the rated load. Okay, if the load is less, the efficiency will come down because it has been designed to operate on that specific load. Okay, although it will work on the less load as well. Okay, but efficiency will come down. Okay, similarly, in the case of an inverter, if the partial load is there, then 85 to 95% of efficiency we are getting from the inverter. And at full load, 90 to 96%. So in a PV system, the size of a grid connected inverter is calculated using the efficiency characteristics of the inverter as well as its overload capability. So ideal system performance can be achieved by using an inverter that has a rating in the range of 70 to 90% as nominal rating of the solar PV array. That depends on the performance of the inverter and the climate involved. So many factors here. They're giving the total output. So this directly affects the output of the whole of the solar system as well. Okay, so for grid tie operation, inverters should match the necessary equipment considering the quality of output voltage and current waveform. That should be the same. Then avoid production of electrical noise that may hinder TV or radio reception. Noise basically what disturbance. So some type of due to this mismatch or switching operation, some type of this rays or the radiation, if they are being emitted, so some type of disturbance could be created. So that should be avoided. And the inverter should be turned off during grid's failure, ensuring safety of engineers present to repair the grid. Similar thing which I just covered in the anti-aligning grid mode. So in the standalone PV system, battery supplies energy to the inverter. So partial load operation of the inverter can be curtailed by sizing the inverter to match the loads. Okay, so here I shall stop. There are some practice questions here as well. So you can try these questions.